Hello, today we'll be doing number 22 from homework 1. So part A reads, what is the frequency of blue light that has a wavelength of 450 nanometers? So we know that blue light has a constant velocity, which is c is equal to 3 times 10 to the 8th meters per second. And we're given that the wavelength is 450 nanometers, so that's 450 times 10 to the negative 9 meters. So now, to find the frequency, we have to use this equation, and it's just frequency is equal to the velocity over the wavelength. So the velocity is c, frequency is equal to 3 times 10 to the 8 meters per second, all over the wavelength, which is 450 meters. And to simplify things, I'm just going to make it 10 to the 9th instead of 10 to the negative 9th. So that's going to be equal to 6.67 times 10 to the 14th. And this is frequency, so it's going to be hertz. Okay, and now we've found part A. So moving on to part B, it asks a very similar question, but this time it has a wavelength of 650 nanometers and the light is red instead of blue. But it's okay because the speed of light is constant, so it's still going to be 3 times 10 to the 8th meters per second. The wavelength this time is going to be 650 nanometers, which is going to be 650 nanometers times 10 to the negative 9th, meters. We're going to use the same equation where the frequency is equal to the velocity over the wavelength, which is equal to 3 times 10 to the 8th meters per second, all over 650 meters times 10 to the 9th. And we get an answer of 4.62 times 10 to the 14th hertz. So our answers so far for A are 6.67 times 10 to the 14 hertz and 4.62 times 10 to the 14 hertz for B. Now part C reads, what is the index of refraction of a material in which the red light wavelength is 450 nanometers? So this is asking us essentially for n. But in order to solve for n, we need to find the new velocity. So this time we're going to be looking for velocity. So we're going to use the frequency that we found in part B and the new wavelength of 450 nanometers. So this time we're looking for V. So it's going to be V is equal to the wavelength times the frequency. V is equal to 450 nanometers times the frequency of 4.62 times 10 to the 14 hertz. And this is going to be 450 times 10 to the negative 9 times 4.62 times 10 to the 14. And we get an answer of 2.1 times 10 to the 8th meters per second. So this is our new velocity. But now we have to find the index of refraction. And the index of refraction is basically the measure of extent to which a substance slows down the light waves passing through it. So the formula for this is simply V is equal to C over N. So we'll just plug in the numbers into the equation. We'll get, let me do it over here. 2.1 times 10 to the 8th is equal to the constant c, 3 times 10 to the 8th, all over n. So n is equal to 3 times 10 to the 8th meters per second, all over 2.1 times 10 to the 8th meters per second. So the meters per second cancel out, and we're left with n is equal to 1.5. So our refraction, index of refraction is n is equal to 1.5. And we solved number 22.